Before you get started, this video does contain spoilers for Inanimate Insanity 15. You should probably go and watch that first. Like, right now. Go watch it right now. Also, as a disclaimer, this video is completely unprofessional. All the information that I'll provide throughout this video is purely speculation and has not yet been verified by an expert. If you have any additions or corrections to this video, please feel free to comment below. Anyway, I hope you enjoyed the video. The newest episode of Inanimate Insanity is amazing. I should know, I was at one of the meetups. Inanimate Insanity 15 has recently released 4 years after its previous episode, and it came back swinging with a new musical number, Taco's Tirade. It's a villain's song? A song about Taco's current relationships with the contestants and the game as a whole, moments before she steps in and reveals her presence. It's a good song. I like the song. You know what I also like?
Welcome to us. Click the circles.
Okay, well, aside from that, I also map. I like making beat maps. And as your certified local object show community Osu mapper, when I first heard Taco's song, you best believe what I had to do. I gotta try mapping this. Now, as of making this video, there is unfortunately no official release of Taco's Tirade yet. Hi, it's August 17th and I'm updating the script and they just made an official release a few hours ago. There aren't any major differences from the in-episode song aside from diegetic audio, but if I wanted to try mapping the song, I figured I would have to start early because of one specific problem. The tempo changes. Taco's Tirade is a very dynamic song. In the verses, it starts off pretty slow.
But history is rearranged just to credit those who win the glory.
And it speeds up during the choruses.
But I will break this cycle of mistakes.
Now, you know how I said there was one specific problem? Well, I lied. Because that wasn't the problem at all. The problem is actually much worse. The tempo gradually changes. To explain why gradual tempo changes are stinky poo-poo for beat mapping, let's start with something simple. This is a graph of a discrete tempo change. It's pretty straightforward. On one side is one speed, and on the other is a different speed. On Osu, I can directly translate this using 2 timing points. In fact, as long as a song can be directly translated into discrete sections of tempo, it's pretty easy to accurately time it. Even songs with gradual tempo changes that are made in discrete sections are easy to work with. Now, what happens if there's more of these changes? More. This leads to a continuous tempo change, or a gradual or linear change. In the context of Osu, this is an immediate problem. You see, I am only able to use discrete tempo changes, and gradual changes are essentially made of these infinitely small discrete changes. And aside from the fact that there's no way in idiotic island that I'm going to make infinite timing points, I also don't have a reliable way of predicting a linear tempo change. But how do I know that Taco's Tirade is linear? Well, it went something like this.
To feel this pain.
Yes, okay, something changes here. I'll come back to it. Let me do the major BPMs first.
Break this cycle of mistakes, unlike all of these snakes whom I call to.
Uh-oh. Usually there is some intuition when timing a song. Most songs are digitally produced nowadays, and often the least passive resistance is to find some sort of incremental pattern in the BPMs. But no, you see, Taco's Tirade looks more like this. I resorted to trial and error to manually time and guess the different tempos of the song by ear. So again, at least there is still some intuition in predicting certain changes. I'm pretty sure I'm still a bit off, but this was probably the closest I could get, at least for the basis of a beat map.
glory, and we choose to feel this pain. And we lose more than we gain. But I will break this song.
So the song has linear tempo, and I can only use discrete tempo. The best thing I could do is average things out using the discrete technique I mentioned earlier, right? This proposition was a fatal error, one that would lead me to an unexpected and complicated, but also an interesting journey about math in music.
1, 2, 3, go!
Let me explain what I mean by averaging things out. Here is an example tempo graph. Let's say I want a song to go from 120 to 180 beats per minute, in the span of 4 measures or 16 beats. I can divide this graph into many sections, and in each section I can get the average tempo, which is just the midpoint between the lowest and highest tempos. This method results in a linear set of discrete changes. That is, there is a constant rate of change between each new tempo, and using this list of average tempos would theoretically allow me to estimate how long each beat takes during the linear change. More divisions would mean more precision.
Word.
Now, timing a map in OSU is already hard. Timing a map in OSU and using Desmos in the background is even harder. And as a computer engineering major, I'm really lazy, so instead of doing that, I wrote a Python script to do the work for me. In this script, I set up parameters that can help me control the linear change, such as the starting time and target BPMs. The beat resolution sets the amount of beats for a single division. For example, a resolution of 0.25 means each BPM change in the game will last a quarter note. A resolution of 0.5 means it will last half a note. So an amount of 16 beats with a resolution of 0.25 means that the linear change will occur over 16 quarter notes, or 4 measures. To properly test the script and really make sure it works, I exported a small track that goes from 120 to 180, as well as 180 to 120, both in 4 measures. I threw the track in OSU and also bookmarked the exact starting and ending times for each change as a comparison. Run the script, paste it over here, and... it sounds close, but it's not close enough. Actually, it's not even close at all. The finding timing point is almost 30 milliseconds too early, and if you are familiar with rhythm games, that's bad. Like, really bad. Well, maybe this test was a fluke. Perhaps Taco's Tirade may fare better?
Glory, and we choose to feel this pain. And we lose more than we gain. But I will break this.
That's worse. So what went wrong? A common reason for errors in mathematical problems is often making false assumptions. In this case, I falsely assumed that the change in tempo was linear. Wait, you're telling me that linear tempo changes aren't actually linear? Yes. Kind of. Look closely at the graph. This is a graph of tempo with respect to beats. When I was taking the average tempos of each section, I really should have been taking the average time a beat takes within each section. Before we find an improved method, let's see how beat length is impacted by tempo. All of us are pretty familiar with the term BPM, or beats per minute. For example, a BPM of 120 means that there are 120 beats or quarter notes played in 1 minute. But we can rearrange this. Change this to seconds, take the reciprocal, and now we have seconds per beat, or SPB. Now let's take this a step further. Let's say we have 2 BPMs, 60 and 120, and they are linearly connected in terms of beats. Their SPBs are 1 second and 0.5 seconds respectively. If we take the average of the SPBs, we get 0.75 seconds, meaning that on average a beat lasts 0.75 seconds during this interval. But if we take the average of the BPMs, we get 90, whose SPB is 0.667 seconds. This notion explains why the first method was yielding earlier timing points. Each beat was taking up less time than they should have been. This stack exchange post gives another example of this, which is where I base my next method off of. Let's say we want to change the tempo from 100 to 200 within 40 beats. The average SPB between the two tempos is 0.45 seconds, and multiplying this by 40 means that this gradual tempo change should last up to 18 seconds. We can represent this linear SPB change using a straight line. I reworked a bit of the formula that was provided in the stack exchange post, but this is what it generally looks like. This function represents a linear change in seconds per beat between two tempos over a given amount of beats b. T1 and T2 represent our two tempos, and n represents some point during the linear change. Notice how I use the SPB formula, 60 over t, in order to calculate the SPBs of the two tempos. Let's use our track example using 120 and 180. Their SPBs are 0.5 and 0.333 respectively, and let's set beat at 16 again. This is what the function looks like. As you can see, the SPB gradually decreases as the tempo increases, since each beat starts to take up less time. I proceeded to plot some of the BPMs as well. As you can see, this growth is barely not straight. Now, we can use the same division technique as before, and instead of getting the average tempo, we can get the average length of each beat instead. The last thing we need to do is convert these values back into BPMs, which is a simple rearrangement. That was a lot to take in. Here's the code of the second method. I'll spare you the details of how I implemented it, but just know that I also integrated the ability to change beat resolution here, which fortunately doesn't require any major formula changes. Run the script, paste it again, and... that's even worse, like laughably worse. I proceed to explain all the stupid math, made an entire Desmos demonstration about it, and I get this pathetic excuse of a... well... oh, you wanna see Taco's Tirade too? I forgot we were talking about that. Okay then.
And we choose to feel this pain, and we lose more than we gain. But I will break this cycle of unloved.
So we definitely know something went wrong. Remember when I said that many math mistakes are often due to false assumptions? Well, the same thing happened here. This time, we assumed that the change in seconds per beat was linear. This linear tempo change is looking less and less linear. I cannot rigorously prove why or how this method is invalid, but I'll try my best to explain my reasoning through this problem, since it is very subtle. Let's take a look at our simple graph again, a linear tempo change from 60 to 120 BPM for some interval. Let's look at a very small beat resolution, delta B, and for each of these resolutions, the tempo changes by some delta T. Since the tempo changes, we also know that the SPB changes, so I'll also add that value to the bottom, delta SPB. This is how much the beat length changes across the beat resolution. Now, watch what happens when I sweep this resolution across the interval. Earlier, we declared that the SPB changes linearly over each beat, meaning that this delta SPB should always be a constant value. However, it's, well, changing. Every time we move a fraction of a beat, we wait some amount of time to move forward closer to the next beat. The amount of time we move forward depends on how long a beat is at that moment, the SPB. But every time we move forward, there is a change in SPB, which changes the time we move forward. But how much the SPB changes also changes, so the SPB changes a bit each time, which changes the time we move forward, and you get what I mean. Essentially, the change in the length of a beat is dictated by the tempo, which is based on the length of a beat itself. It's kind of like a small population of bugs. At first, they start reproducing slowly, but as more and more bugs appear, their population exponentially and naturally grows faster. Naturally. Natural. That sounds familiar. I would like to remind you that this whole thesis all started just because I wanted to map a singing taco in a circle clicking game. At this point, I was caught up with this problem for 2 days, and I immediately knew there was no turning back the moment I started bringing out the sheets of paper. This is actually the only piece of paper. It helps me visualize things. Let's take a look at that SPB formula again. And remember that SPB stands for seconds per beat. This time, let's graph the formula, a function of seconds with respect to tempo. It's not linear. It's a reciprocal function, which makes sense. As you increase in tempo, there is less of a distinguishable difference on the amount of time a beat takes. Realizing that SPB is not a linear function is a key step in creating a new method. Now let's bring in our tempo graph as well. Remember again that this is with respect to beats. Let's use a big interval this time. Within one beat, let's say that the tempo changes from 60 to 80. Looking at our SPB graph, this means that the SPB changes from 1 second to 0.75 seconds. Within one beat, our tempo encounters all these different lengths that a beat could be. This function contains the info on how much the beat length changes. This is the function we should be averaging. Now, previously, we were able to calculate the averages of our functions quickly since they were all linear. What happens if the function is not linear? Well, I'm afraid this requires us to consult the ancient scrolls of mathematics. We must summon a lifelong veteran, one deeply experienced in a world of endless possibility, a world of infinitesimal summation. We have to integrate. Wait, hold on, don't go. Now, explaining why this integral shows up in the first place would require a few crash courses in calculus. But to put it simply, you know how we were able to find the average of linear functions by adding values together and dividing them? Well, think of the integral like that, but on steroids. This half of the formula essentially does all of the adding, while this half does all of the dividing. Here, T1 and T2 refer to our starting and ending tempos respectively. Evaluate the integral and simplify a bit, and this is the general expression for the average length of a beat during a gradual tempo change. It uses a natural logarithm. Now, that's only the first half of the problem. How do we apply this for the entire tempo change? Let's go back to our two graphs. Notice that by applying this integral, we have actually found the average beat length for this single beat. After converting the SPB to a BPM, I can safely say that the tempo has changed from 60 to 80. This can be said for the interval from 80 to 100 and 100 to 120. Notice that we aren't actually changing our own tempos linearly, but instead we're simulating different tempos to ensure that for each beat, the expected tempo changes linearly. This is what we were trying to do in the previous method, we were just using the wrong function. You may also notice how close these BPM values are, as if we took the average BPMs instead, like in the first method. This consolidates why method 1 sounded pretty close, but was barely off enough to cause a consistently early offset. Both previous methods were onto something in their own right. Method 1 took advantage of literal linear tempo changes, while method 2 took advantage of beat length approximation. You know what they say. Well, no more dilly-dallying. Let's code this in, run the script, paste this here, and... It's perfect. There is one thing I forgot to mention earlier. I kind of cheated. Remember when I talked about beat amount and beat resolution a long time ago? Well, those are actually important to how I implemented this third method. Let me explain. The beat amount is how many beats that the tempo change will occur over. Beats based on the beat resolution. In other words, it's how many different discrete tempo changes that will occur to get from the starting tempo to ending tempo. In the script, there is another parameter I added called bins. This parameter splits up the SPB graph into a separate amount of sections, in which I can integrate and find the average SPB for each one. Now, for each beat, I can sweep through the integrated SPBs to add some needed amount of time until I hit the next beat and create a new tempo change. The specific amount of time I add also depends on the beat resolution as well. I allowed these options to be separately modifiable, so I would have more or less some leniency while timing for a couple of reasons, which primarily involves the idea of timing an Osu beatmap in general. However, I'll explain that pretty soon. All you need to know is that this bin system takes up like 80% of the code, and that I did have to use the bin system a lot in Taco's Tirade. Speaking of which,
When they spin the story and we choose to feel this pain, and we lose more than we gain, but I will break this cycle.
so after 2 days of mathing and coding, 5 days of script writing and even more coding, and
4
days of video editing, what was the point of all of this? And to that I say, that's a good question. How did I even get here? I think the most reasonable question to ask from here is this method accurate? The last method is definitely the most reliable out of the three, but it's hard to say whether it's 100% accurate or not. It still requires a bit of user manipulation to get timing points that feel right. I think a big hint to this is when I set the amount of bins very high. Theoretically, this should give me more accurate SPBs, but the final timing point ends up coming a bit short. After I wrote the script, I continued to research about this topic a bit more, and eventually found 2 more websites. This Reddit user made a post on r/askmath talking about the same things. Like, literally the exact same things. They went through the same 2 incorrect methods I went through, and even referred to the same Stack Exchange post I ran into earlier. Another user provided a well-in-depth response to the problem, and although their approach was slightly different, they seemed to arrive at the same formula I was getting. The other website was a gradual tempo change calculator developed for a different rhythm game, Stepmania. The creator of the spreadsheet mentioned that they also use calculus, and my results were also lining up with theirs. My only reasoning for these inconsistencies is that my DAW or other DAWs are estimating these SPBs at a different accuracy or with a different way. Maybe they use less bins, or there is a 4th method I'm missing completely. Ultimately though, it does raise the question of how these music softwares calculate BPM changes, and I wonder if it could be explored more in the future. Now, as for making an Osu beatmap itself, is this practical to do in the first place? To that, I can safely say that it depends. Osu does require rankable beatmaps to be accurately timed, but the definition of accurate is actually a bit loosened in this context. There are rarely any songs with variable tempo that get mapped in Osu, but when they do, it's usually best to take the path of least resistance. That is, you want to have enough timing points so the map feels accurate, but also minimize the amount of changes so it remains intuitive to play. These 2 videos made by Pishufat go over this in more detail, and I highly recommend you watch them for a better idea. This is why I opted to time Taco's Tirade using a half-note resolution. There are enough points to keep at the song speeds, but not too much such that it would interfere with mapping or playing. It's also important to point out these sections where I seemingly just don't use my script at all. I eventually caught on that these sections seem to stagnate at around 136 or 137 BPM, but the rhythm fluctuates enough that it warrants me to control the timing manually. This actually goes to show how particular and well done the instrumentation is in Taco's Tirade, and I do want to commend the crew for putting together such a unique song. And I guess the last question is, am I still going to map this song? I maybe expended a bit too much energy writing an entire dissertation on a song that I don't even plan on trying to rank in the first place. But we'll see. Beyond all of this though, this experiment was strangely poetic, to put it one way. It involves so many of my interests: object shows, math, music, mapping, coding. It's been a while since I've been this passionate about something, and I think it's just so cool to experience this feeling again. Not holding back, not being afraid to be yourself or do things yourself or show what you can do. Heck, I helped produce a song about that very same feeling. And it all started because of a show about inanimate objects. The more I listen to Taco's Tirade and the more I learn about its lyrics, I can kind of empathize with where Taco is coming from. Maybe not the whole sabotaging other people just to remedy your feelings but feeling like an outcast is hard. I mean, we say and do the craziest things just to feel included. Things such as doing calculus on an object show. Why did I leave that in there? And more often than not, that feeling eventually takes its toll, either on ourselves, on others, or both. I'm still working with that feeling myself. There's many reasons why we could feel like this, and I can't speak for Taco, but for me, it personally felt so liberating again to create something just for the sake of creating something. Just to be the real, honest you as you currently are. If we live conditionally with others, whether we succumb to them or fight against them, we're never going to find a place to stay. But if we can live unconditionally with ourselves and care and respect ourselves, then maybe you'll always find a place to stay. That or I'm saying complete garbage. They're literally just objects. Aye, crew, if you see this, please let Suitcase win, please.